Hi, myself Karan Udhavan. Today I'm going to explain a problem statement which is to find two elements such that the sum is closest to zero. Let's look at the problem statement where a list is given that contain a positive and negative integers. One needs to find two elements such that the sum is closest to zero. So we are having two test cases, test case 1 and test case 2. So the hints are here. The sum can either be positive or negative, but the absolute distance of the sum from 0 should be considered to find the sum closest to 0. Second hint, assume that the maximum possible sum of any two elements in the list is 10 billion. Inbuilt sort may be helpful in this problem. Method 1. Brute force approach. The code defines a function summin that takes the list first and its size first underscore size as parameters. It checks if the list has at least two elements. If it doesn't, it prints invalid input and returns. The code initializes min1 and minr as the indices of the first two elements in the list and minsum as the sum of those two elements. The code uses nested loops to iterate all over all possible pairs of elements in the list. The outer loop iterates over the indices 1 from 0 to first underscore size minus 2, and the inner loop iterates over the indices r from 1 plus 1 to the first underscore size minus 1. For each pair of indices 1 comma r, the code calculates the sum of the corresponding elements first 1 plus first r. If it then checks if the absolute value of min underscore sum is greater than the absolute value of the current sum. If it is, it updates min underscore sum to the current sum and updates min underscore 1 and min underscore r to the corresponding indices. After iterating all over the pairs, the code prints the elements corresponding to the min 1 and min r, uh, which are the two elements with the smallest sum. Finally, the sum min function is called with the list first and size first underscore size to execute the code and find the pair of elements with the smallest sum. So the Python implementation of the code is here as follows. First we'll take a list and we'll take an input variable to define the length of the first list. So we define one sum min function and the list should have at least two elements. If first size is less than 2, it will print invalid input, and after that we will do the initialization of the values. Then we will come to the for loop. After that we will print the sum of two elements whose sum is minimum. So now I'll explain method 2, which is the two pointer approach. The function find underscore closest underscore sum takes a list first and its length n as input. The list is sorted in ascending order using the sort method. This step is important because it allows us to use the two pointer approach effectively. Two pointers left and right are utilized. Left points to the start of the sorted list index 0 and right points to the end of the sorted list index n minus 1. The variable min sum is initialized with a large value float to track the minimum sum found so far. The variable min pair is initialized as none and will store the pair of elements with the sum closest to 0. And if condition checks if the input size n is less than 2. If it is, the function prints an error message and returns none, indicating an invalid input. A while loop is used to iterate until the left and right pointers meet or cross each other. In each iteration, the current sum of the elements at left and right indices is calculated and stored in the variable current sum. The absolute value of the current sum is compared with the absolute value of min sum to check if it is closer to 0. If it is min sum and min pair variables are updated with the current values. Depending on the current value of current sum, the left or right pointer is moved towards the center of the list. If current sum is negative, it means the sum is smaller than 0, so left is incremented to consider a larger element. Otherwise, right is decremented to consider a smaller element. Once the while loop finishes, the function returns the min pair, which contains the pair of elements with the sum closest to 0. In the main part of the code, the sample list is defined and its length n is calculated. The find closest term function is called with the list and length as arguments, and the result is stored in closest pair. Finally, the closest pair of elements is printed as output. Python implementation. We define the function find closest sum Then we sort the list in ascending order. After that, we initialize it with a large value. Then we use the if loop. After that, we create a list, then print the two elements whose sum is closest to 0. Now relevant data structure used. In method 1 and 2, the data structure used is the given input list. It holds the elements for which we need to find the sum closest to 0. Hence, it acts as the primary data structure to store the numbers. Edge cases to consider. Empty list. The code should handle the case when the input list is empty. It should either return an error message or handle it gracefully without any issues. Single element list. The code should handle the case when the input list contains only one element. Since finding a pair requires at least two elements, the code should handle this scenario and either return an error message or handle it gracefully. List with duplicate elements. The code should handle cases where the input list contains duplicate elements. It should correctly identify the pair with the minimum sum considering all possible pairs. List with only negative or only positive numbers. The code should handle cases where the input list contains only negative or only positive numbers. It should correctly identify the pair with the minimum sum taking into account both positive and negative numbers. Evaluation of approach efficiency. Time complexity. Method 1. The time complexity of the code is n squared 2, where n is the size of the input list. There are two loops used in the code. This results in a nested loop structure, causing the code to compare all possible pairs of elements in the list. Since both loops iterate over the entire range of indices, the time complexity is proportional to the square of the number of elements in the list, leading to n squared 2 time complexity. Method 2. The time complexity of the code is dominated by the sorting operation, which has a time complexity of n log n in the average and worst case, where n is the length of the input list. The while loop that iterates until the pointers meet or cross each other takes n time as it performs a linear scan of the sorted list. Therefore, the overall time complexity of the code is n log n due to the sorting operation. Evaluation of approach efficiency, space complexity. The space complexity of the code 1, 2 in method 1 and method is constant. The code does not utilize any additional data structure that grow with the input size. It only uses a few variables to keep track of the indices and minimum sum pair, which require constant space regardless of the size of the list. In method 2, the quicksort function also operates in place and does not require additional space. Therefore, the space complexity is 1. Evaluation of approach efficiency, handling large inputs. Method 1. The code you provided has a time complexity of n squared 2 due to the nested loops, where n is the size of the input list. In the worst case scenario, when the input list is large, the code may take a significant amount of time to execute. If the input list is extremely large, the code's performance may be suboptimal, hence it is not suitable for large inputs. Method 2. The two-pointer technique used in the solution is well suited for the handling large inputs. The algorithm doesn't rely on creating additional data structures proportional to the input size, ensuring that it can handle large lists without excessive memory use. The time complexity n log n also allows the solution to scale well, making it efficient for large inputs. Conclusion. The solution provided earlier is fast and efficient for the given problem. It has a time complexity of n log n, a space complexity of 1, and is well suited for handling large inputs. It optimizes the search for the closest term by utilizing the two-pointer technique after sorting the list.